Hi, Math A. We are going to be doing 1.2b today on rational number ordering and estimation. So it says plot each fraction on the number line below. So let's start with half. If I'm going to plot this on the number line, here's 0 and here's 1, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. So I'm just going to count 1, 2, 3, 4, 5. Right here, we would have half. If I'm going to do 1/3, I'm going to approximate 1/3 is 1/3 of 10 sections. So 1, 2, 3, and just a little bit more. So another third here. So this would be 1/3. If I'm going to do 3/4, 3/4 would be 7.5 out of 10 sections. So this is 6, 7, 0.5. This is 1, so it's halfway in between half and 1. So this is my 3/4. And then finally, if I have 2/5. So 2/5 could also be written as 4/10. So I'm going to count 1, 2, 3, 4. And this right here is 2/5. Okay, B says compare the fractions using less than, greater than, or an equal sign. So this sign is less than, greater than, or an equal sign. So half or 1/3. Well, if I think about, obviously I think about food. So if I have a brownie and I break it up into 2 pieces, that's going to be larger than if I break it up into 3 pieces. So 1/2 of that brownie is larger than 1/3. If I'm going to think about this as 2/5 or 3/4, I could draw a bar model if I wanted to. So I have 2 separate bar models here actually, and these are both, let's pretend they're both one brownie. So I have 1, 2, 3, 4 sections, and I have 1, 2, 3 shaded, or I have 1, 2, 3, 4, 5 sections, and I have 2 sections shaded. Well, 1/5 is actually smaller than 1/4 already, and there's more fourths than fifths. So this is going to be 2/5 is less than 3/4. What differences do you observe when comparing the fractions in part B? Well, I would say that the larger the denominator, the smaller the fraction. The larger the denominator, the smaller the fraction. So the denominator is that bottom number of the fraction. So 1/3 is larger than 1/2, which means it's smaller than 1/2. You're breaking that into smaller pieces. So how does the number line help you determine which number is larger? Well, the number line would help us determine if we're going to look back up here, because if I'm going this way, these are positive and larger numbers. If I'm going to the left, these are larger but negative numbers. So numbers to the right are always larger. To the right are larger than numbers to the left. All right, classify these fractions as 0, close to half, or close to 1. Okay, well, if we're going to classify these fractions, I would start with the easiest ones, and I think the easiest ones are the ones with 1 in them. Because we just said that the larger the denominator, the smaller the fraction. So if I come down here, well, close to half, I know that half is close to half. I know that 1/9 is a lot closer to 0 than it is to 1, because 9/9 would be closer to 1. 1/5 is less than half, because if I think of 5 cups, half of 5 cups would be 2.5 cups. So 1/5 is a lot closer to 0. So I've used this one, and this one. And 1/7 again is closer to 0. Okay, so now I'm going to think about what is almost 1. and I look at this 7/8, I know that 8/8 would be 1, so 7/8 would be close to 1. And 5/6, well, 6/6 would be 1, so 5 out of 6 would be close to 1. 5/8, well, we know that half is 4 out of 8. So I would say that 5/8 is close to half. 5/9, well, half of 9 is 4.5. So 5/9 is pretty close. And then 3/8 is close to 4/8. That's, again, close to half. So now order the fractions from least to greatest. Well, we kind of did this almost. If I'm going to think about the smallest of these numbers, it's the one with the largest denominator. So this is 1/9, and then 1/7, and then 1/5. And then I have to think about, okay, what's close to half? Well, 3/8 is smaller than 5/8. So 3/8. And then 1/2 is exactly 1/2. These ones are kind of tricky. We're going to come back to these. 5/6 is smaller than 7/8. And then 5/8 and 5/9. Well, I have to think, is 1/8 smaller or is 1/8 bigger than 1/9? And if I had a brownie and I divided it into 9 sections for 9 people, that would be smaller than if I only had to divide it 8 times. So 1/8 of a section is actually bigger than 1/9. So that means that 5/8 is bigger than 5/9. Great. So next page here. Okay, approximate where each value is located on the number line. State a common fraction and decimal you can use to help you find the approximate location for each. The first one is done for you. Okay, so this first one is A. 0.32 is approximately 0.3 or 1/3. So on my number line, I'm going to go to 1/3, which is 1, 2, 3, and another little third. So this would be A. B would be 0.67, and this is approximately 0.7 or 0.6, really. As a fraction, we can say this is 2/3. If I'm going to put this on the number line, 2/3 is 3 boxes, is 3 and 1/3 is 1/3. So 2/3 is another 3, 1, 2, 3, and another third. So right here would be B. C is 0.76. Well, I'm going to approximate this to 0.75 because I know 0.75 as a fraction is 3/4. So 0.75 or 3 out of 4. And I know that that can be 0.75 would be 7.5 boxes. So 1, 2, 3, 4, 5, 6, 7.5 is about right there. That would be C. 0.98, you know what? I'm just going to say that this is about 1/1. So I'm going to put D right at 1. 0.18, I'm going to approximate this as about 0.2 or 1/5 as a fraction. So 0.2 would just be 2 boxes out of the 10 that we have here. So 2 would be E. And then finally F, 0.06, I'm going to approximate this to 0.1 so that I can make it right on the line right here. And this is going to be F. Okay, this next part says plot each fraction on the number line. Fill in the blank with a less than, greater than, or equals to sign. Okay, well, there's a couple of different ways that we can think about this. So 4 3/10 is either less than, greater than, or equal to 4 2/7. I know that 4 and 4 are the same, so I'm really just looking at the fraction here. So one way you could do this is to try to get the denominators of the fraction the same. And I know that 7 and 10, well, both of those can go into 70. So if I try and get 10 to 70, I have to multiply it by 7, which means that I have to multiply the top by 7. So 3/10 could also be written as 21 over 70. So this is 4 and 21/70. And then this other one is 4, and if I'm going to try and get the bottom to equal 70, I have to multiply that 7 by 10, which means I have to multiply that 2 times 10. So this would be 20/70. And now it's a lot easier to see. I have 4 and 21/70. That's greater than. This next, oh, I have to plot it on the number line. So 4 and 3/10 and 2/7. Well, this is broken up into 10 boxes. So I can easily plot 4 and 1, 2, 3/10. And then the other one is just going to be a little bit lower than that. Okay. Plot each fraction on the number line, fill in with less than, greater than, or equals to. How do you know your answer is correct? Justify your answer. So justify is basically saying explain your answer. Okay, 0.14, but that bar over the 4 says that that is repeating. So if I were to rewrite this, this would be 0.144444 forever. Okay. If I were to rewrite this other one, 0.14, well, this would just be 0.14. And you could write zeros there. We don't normally write the zeros though. So right away, I can see that this repeating one is going to be greater than. And if I'm going to approximate it, well, this is 0.1 and this is 0.2. I like to rewrite my number line a little bit. So this is 0.11, 0.12, 0.13, 0.14, and that's probably all I need. So my first one would be right on 0.14, and my second one would be right to the right of it, okay? So I should actually do the second one in green because that's this one. All right, this next one, 0.15 and 3/20. Well, I want to make these look the same so that I can figure out which one's larger. So 0.15, I'm going to rewrite this as 15 over 100. 0.3/20, I'm going to rewrite this as, well, I'm going to start with 3 over 20. But I want to make my denominator look like 100. So in order to make my 20 look like 100, I have to multiply by 5, which means on the top I also have to multiply by 5. And I also get 3 times 5 is 15/20. So for here, I just write an equal sign. So if I'm going to plot this point, well, 15 over 100, 10 over 100 would be 0.1, which would be right here. And 20 over 100 would be 0.2, which would be right here. So 15 over 100 is right smack in the middle. Okay, 2 and 2/3 and 2.6. Okay, so 2 and 2/3. Well, I know that 2 and 2/3, 2/3, when you divide 2 into 3, is going to get 2.6 forever, okay? It's going to go on forever and ever and ever. 2.6, though, is just going to be 2.6. So my 2 and 2/3 is going to be slightly larger. So I'm going to write a greater than sign. And when I plot this, well, they already plotted 2.5 for me, so I can already plot my 2.6 right here. And then my other one is just to the right of it, not quite past that 2.7 would be the next one. Okay, next page. Remember, you can pause this lesson at any time. If we're going too fast, you can also adjust the speed on YouTube. Is 0.74 to the left or right of 3/4 on the number line? Explain. Okay, well, 3/4 can be rewritten as a decimal if I were to divide. How many times does, if I were to divide 3 divided by 4, this would get 0.75. So 0.74 would be to the left because 3/4 is equal to 0.75, which is larger than 0.74. Okay, is 1.26 to the left or to the right of 1 1/4 on the number line? Well, 1 1/4. I have to think about what is 1/4 of 100, and then I can rewrite this. 1/4 of 100 is just 0.25. So 1.25, if I didn't know that, I could just divide 1 divided by 4, and then I would get 0.25 using long division. So 1.25 would be smaller. So 1.26 is to the right of 1.25. So this is to the right of 1.25 because 1.26 is larger. Okay, for each problem below, circle which number is bigger. Explain how you know. Well, if I'm going to look at both of these numbers, I see 0.4 and 0.04. I could rewrite this 0.4 as 0.40, which is 40 hundredths, and this is just 4 hundredths. So, or this is actually just 4, yeah. Sorry, getting confused there. This is just 4 hundredths. So 0.40 and 0.4, this would be, this is larger. And if I wanted more justification, I could do, well, 40 over 100 is going to be larger than 4 over 100. So then this number is larger. 0.27 and 0.3, well, 0.3 is going to be bigger because this is 0.30. And that's 30 hundredths, where this is only 27 hundredths. 0.1 versus 0.09. Well, I could always rewrite as 0.10, and 0.10 is bigger than that 0.09. Without using a calculator, determine which fraction is bigger in each pair. Justify your answer with a picture and words. Okay, this would be a really good time to pause the lesson and try these yourself. Okay, so I'm gonna also just stick with the brownie analogy. So if I have one brownie, I'm gonna make it the same size. So one of them is divided into thirds and one is divided into halves. So if I have 1/3 or 1/2, half is going to be a lot bigger. I'm going to want that half. Same thing here. If I have 3/7 or 3/5, okay, I want you to pause the video and just think about part A. Which of the denominators was bigger and which of the fractions ended up being larger? So in part A, 1/2, 2 was actually smaller than 3 in the denominator, but this was actually smaller because you're breaking it up into more parts. So for this one, 1/7, you're breaking it up into 7 parts rather than 5 parts. So if we have the same number, then really this should be larger. And if you wanted to justify it with a picture, you could say, okay, well, if I break something up into 5 parts, 1, 2, 3, 4, I'm just going to make another 5th. Or if I break something up into 7, 1, 2, 3, 4, 5, 6, 7, that does not look right. Okay, let's try that one more time. Okay, I just read through these. So if I have 3 parts of 5, that's 1, 2, 3. If I have 3 parts of 7, that's only 1, 2, 3. So 1/7 is a lot smaller than 1/5, which means if we have 3 and 3, this is going to be larger. Okay. So go ahead and comment on the video on YouTube so that I know you watched it. You can tell me how awesome my YouTube channel is. You can just say hello. This is how I will check that you've watched the video.